All right, guys, we got another one for you. Got some new gear in the shop. Let's see what we got. Okay guys, so this is another one of those videos where it's a shop upgrade, but it's also a fabrication project. So first we'll open up the box. I'll show you guys what's in here, and then we'll start digging into the details on why I decided to go this route. So let's go ahead and open it up and see what we got. So I've got 3 black plastic TIG rod carriers. I've got 3 blue TIG rod carriers. And I've got 3 green TIG rod carriers. I was going to go with red, white, and blue, but they actually don't have white, I believe. So those are the colors I picked. They got like 5 or 6 different colors online. I ordered these through Baker's Gas. I order a lot of my stuff through Baker's Gas. I ordered those last 2 welders through Baker's Gas. They're good to deal with. I feel like their pricing is as competitive as anywhere else I've ever found. Oh, we got a whole slew of Blue Demon stickers. And then the last thing, I ordered 10 pounds of 1/8 inch 4043 aluminum TIG rod, and I'll get to that. And 332 4043 aluminum TIG rod. Okay, so now let's talk about why I ordered this. So I'm going to go through this with you guys because I really hope that it helps somebody else out. It's taken me a while to figure out why I've been having some of the issues that I have lately. So here's what's going down. I mentioned in previous videos that the Syncrowave 250 was acting up. It just seemed like I could not get it to weld right. And I tried wiping down the TIG rod, I tried wiping down the part, and it didn't really matter if it was dirty cast or if it was brand new aluminum plate or what it was. I'd clean it, I'd wipe it down with acetone, I tried all the tricks. Nothing worked. And when I would weld with it, I would get this weird gray, it almost looked like a gray crustacean when I would weld. It wouldn't blend, it wouldn't flow, and it just sucked to weld, and it was extremely frustrating. The last time I welded with it, I got so pissed off, I slammed the torch down on the table, the cup shattered into 100 pieces and went all over the shop. And that was when I was just like, I'm done. I'm going to start looking for a new welder. So I end up purchasing the Dynasty 300. I get the Dynasty 300. It was one of the first nights I had it. It wasn't the first night because I had a job to get out the door. But on one of the first nights I had it, I decided I was going to try out some aluminum. So I grabbed some scrap, cleaned it up, and I tried to run just a regular T-joint with it. It would not run for crap. And I was just like, what is going on? I played with the settings, I wiped everything down with acetone, same thing. All the tricks, nothing worked. Well, as this was going on, I kept thinking there's got to be something going on with that TIG rod. So I'm going to run one with this tonight. I'm almost 100% positive that that's going to be the issue. And I'll show you why. But if you come over here, I've built this little rack, okay? So the TIG rod is off the ground. It's got a little pocket that it sits in. I've got everything nice and neat and organized here. A 10-pound box can just slide right in there. Here's what I think's going on. There's a window right here. And this window, when I have the heater going, well, even now you can see there's moisture in the window, especially when I have the heater going. Condensation forms, it sweats, and I think, this is just a theory, as of right now, but I'm going to prove it here in just a few minutes. I think the condensation is causing issues with my TIG rod. I think that there's Something going on with the sweat, the condensation. It's putting some sort of a film or something on that TIG rod to where it just does not want to run. So that's my theory, and we're going to prove that here in just a minute. I'm going to grab some pieces of scrap. I'm going to run a T-joint and see how that welds. If that welds like I think it's going to weld, then I'm going to scrap every bit of that TIG rod that's been sitting underneath that window, and I'm going to start putting all my TIG rod in a container like this that seals. You can see that they have a rubber gasket there, so when you tighten it down, that should seal out all the air and moisture and everything else from the atmosphere. I'm sure there's a lot of you thinking, well, you should have been doing that from the beginning, and I probably should have. But the last 3 places that I've worked, we live here in Utah and it's dry here. And I've always just kept my TIG rod in the boxes sitting on top of a cabinet or something like that. And it's always been fine. But I think where this has been sitting underneath the window, it's been an issue from the moisture. The other problem, I believe, is the heaters. I love the heaters. The heaters work great. They're extremely efficient. They'll cook you right out of here. But the problem is they don't vent the condensation out through the roof of the shop. There's no vent for this type of heater. That's just how they work. When heaters burn natural gas, they just naturally emit condensation, and most of that ends up in the shop. I do crack the door so that I can get fresh air and also let some of that condensation out. But I think that's part of the problem. I think if I keep my TIG rod in a sealed container, I should be fine. But I just wanted to mention this to you guys because I don't know if any of you guys have had this sort of issue, but I'm pretty sure that this is going to fix the problem. Let's get some pieces of scrap over here. I'm going to run a practice T-joint, see how this new TIG rod runs, and that's going to tell the story. So let's do it. All right, we got those all buffed off. Okay, brand new rod. We're going to see if it's any better. Okay, we got this tacked up. Now let's see how this runs. All right. Well, I think that proves the theory. Obviously, the scrap is not the cleanest, but that didn't run anything like that stuff over there. And just to prove my theory, I'm going to grab another piece of rod from over here and we'll try it. I didn't get any of the crustacean type stuff on that one, but I can tell you what a difference there is as far as the amount of black crap that's floating in the puddle. I'm telling you, there's something going on with storing my TIG rod there. I think it's a good lesson to me to try to pay more attention to how I store my rod. I think sometimes as welders, we focus so much on the material and the machine and all the components involved, but maybe not as much on the rod. I think we just think it's going to heat up to the point where it could melt metal, so it's going to burn the impurities out of there. And I think in a lot of cases it will, but I think aluminum specifically is one of those things you've got to do everything you can to try to keep it as clean and as protected from the atmosphere as possible. So it was a good lesson to me. I'm going to show you guys this. So here was the first one, and it's not the most beautiful bead either, but you can see it's a lot more bright colored and shiny. And if you look at this side, there's all kinds of black crap floating on the top of that. So there's definitely something going on. And if I have to throw away a box of TIG rod and clean everything up, then I'll do it. I want to find a completely different place to put my TIG rod. So tonight we're going to fabricate a new bracket for the TIG rod. So I'm going to go over to the burn table, start drafting something up, see what I come up with. What's up, guys? We're back out in the shop tonight. It's been a few days since we've worked on our TIG rod holder brackets, but we're back out here tonight and we're going to see what we can get done on these. Just to bring you guys up to speed on where we're at, I did get a couple pieces drafted and burned on the burn table. So I got those pieces, and then I've got these two pieces, these backer plate pieces, and they have a couple holes in them so that we can screw them into the wall. I didn't figure you guys needed to watch me screw around on the burn table for hours on end trying to get this design worked out. But I did get it worked out, and I do like it, and I do think it's going to be very functional. I think it's going to work well. So what we're going to do, I've got to lay this out. So I'm going to take a Sharpie and I'm going to pull 2.5 inches in. I'm going to break either end on this. So I'm going to break the ends in, and then this backer plate will weld to that. So it's basically going to be boxed in on 3 sides on the end, which is going to give it more rigidity. So I think that's going to work well. So I'm going to grab a Sharpie and a square. We'll go ahead and get this laid out, and then we'll get them broke, and then we can start fitting. So let's go to that point. Okay, so because this is diamond plate, I want to make sure that my diamond design is on the outside, just because I think it's going to look cooler. It's more of an aesthetics thing. So we're going to make sure the diamond design is on the outside. So I'm going to go ahead and lay out my break lines on the inside, on the smooth side. So I'm going to pull 2.5 inches off the end. Now when I do this, I'm going to make sure that I double check my measurement. Once I get both ends laid out. As you guys know, I like to use a Sharpie whenever I'm working on stainless or aluminum. It just shows up a lot better. Okay, so now what I'm going to do is I'm going to pull my tape measure. Okay, so we're good, 36 inches. All right, so now we'll go over and we'll break these. This diamond plate usually breaks pretty well. They're a little bit overbroke, but that's all right. We'll be able to tweak those back. The aluminum's a lot easier to tweak back than the steel. So we got those broke. Let's get them over to the table. All right, guys, we've got the Dynasty rolled out. We are on high freak AC TIG. I've wiped down all my parts with acetone, and I did just tweak these just a little bit just to get them back to square. So we should be ready to start fitting now. So I think the way to fit this, I'm going to stand these up like so. I want my diamond pattern to be facing down. I'm going to set this piece in here, and I'll tack it up this way because I'm going to have an open corner joint. I'm just going to stitch weld it. With what this is holding, stitch pattern is going to be just fine. It's going to be strong enough. And I'm afraid if I put too much heat into this, it's just going to banana. So and it actually worked. Okay, so now I'm going to try to do this other corner. This is a little bit tricky. Sometimes when you're doing this by yourself, you got to get a little creative. So I've got some 4043, 332 TIG rod here. That's what we're going to use. See what we can do. Okay, so we got our tack on that. Now we're gonna get some tacks on where our stitch welds are gonna go. So this is how I like to do it. I like my stitch welds to be symmetrical. I like them to be uniform. So I'll take my tape measure, and I know that I'm 36 inches. So I'll take and I'll mark center. So center is 18, and I'm gonna do 2-inch stitches. So I'll go 1 inch on either side of the 18. So 17 and 19, okay? Then I'm gonna mark my stitches that are gonna be on the end here, 2-inch stitches. So I mark 2 inches there and here. Then I'll take and measure it between those two, and it's 15. So I will mark 7.5, and I'll go 1 inch on either side of 7.5. So 6.5 and 8.5. Same thing on this one. And then I've got a symmetrical stitch pattern laid out. And your gaps between your stitches should all be symmetrical, which they are. Okay, I'm gonna kind of cheat this one. When I say I'm gonna cheat it, I'm gonna tweak this piece. I'm gonna tweak it. I'm gonna bend it inside so it's got kind of a curve in, just a little bit, so that it's enough to hold the top plate up. And then I'll just kind of massage that until I get a nice, perfect open corner. So I've pulled this out. That's right where I want it. I'm not gonna touch it now. I'm just gonna go ahead and get a tack right there on that joint. I'm using 332 tungsten, and I'm using a number 8 cup with a gas lens. Okay, then I'm gonna do the same thing with these other two. This one's right where I need it, so I'm gonna get some tacks on it. And I am gonna turn up my balance just a little bit because I want it to clean more. So I'm going to 65, and I'm actually gonna go up on my hertz as well. I'm gonna go to 100 hertz, just because these open corners on 1/8 plate, you want more of a concentrated arc cone. And if you increase your frequency, that's gonna help with that. So let's try that. Which it did help. So now I'm gonna tweak this out, get that just where I want it. Okay, I like that. So this is what they're gonna look like. They're gonna hang on the wall like this. TIG rod holder's gonna lay in here in these slots. I can hold 10 of those tubes. I've got my diamond pattern facing out because that's the more aesthetic side. And I do have some mounting holes in there to screw them into the wall. So we'll jump over into time-lapse mode. I'll go ahead and get this other one fit up and welded out. Once we get these welded out, we'll come back to you. I'm gonna clean them up a little bit, and then we'll start getting them ready to get mounted on the wall. So let's go to that point. All right, guys, I want to show you real quick how these turned out. I think they turned out pretty good. Just a few stitches there. and I did hit it with a Scotch-Brite pad to clean them up. So now they're ready to mount. So I'll get these set up over there and I'll show you guys what I got planned to mount these and how I want to set them up. All right guys, so this is the spot I want to utilize for my TIG rod rack. And there's a stud right here and a stud right here. So I think I'm actually going to put one here and one here. I do have an airline valve here and an outlet here, so I don't want it to interfere with that, and I don't want to be too close to it. So I think I'm going to say 2 inches below the top of the wafer. This one isn't going to be rocket science. And I'm going to mark that first hole. I can see that it's in line with the stud. Drill my pilot hole. And we did hit our stud. So I'm using 1/4 by 1.5 inch lags. So I'm going to get this first one started. Just get that snug. Okay, now I'm going to take my level. And I moved it, so I get to do it again. Okay, now I'll drill this pilot hole. And I hit the stud on that one too, so. Check it one more time. Solid. One down. So now I'm going to take and measure the top of this. Exactly 3 inches. So I'm going to go ahead and make a mark. 3 inches. So they look like somebody cared when we hung them. So this one did warp a little bit. But when I anchor it to the wall, I don't think it's going to matter. Okay, so it's just snug, so I can still move it. I'm going to double check this measurement. Right on the money. And I'll go ahead and level this. Okay. Okay, I like it. We can go ahead and get our TIG rod all transferred over into the tubes, and then we'll start assembling these. So we'll go into time-lapse mode for that. All right guys, so we got our rack all done. You can see I've color coded the TIG rod. So for me, I decided I would do mild steel in black, aluminum in blue, and stainless in green. There's tags right here that hang off the end of each tube, so I'll be able to label each one with what size it is. I think this is just going to be a lot better system. I like that it's not underneath the window where moisture can get into the material. It's cleaner, it's more organized. I am going to get one more tube for this top section, and I'm going to put my silicon bronze in that. This should be just about everything I need. I think this is going to work out good. Getting more organized in the shop is always a good thing. So, all right, guys. So I think that's going to wrap this project up. Hope you guys enjoyed it. Hope you guys learned something. We appreciate you guys watching. Remember to like, subscribe, and share. I will see you on the next one. Because it's taken me a while to figure this out. It's taken me a while to figure out. But the one problem that I have seen from those heaters is they don't vent. They don't vent out of the top. The other problem that those heaters don't vent the condensation. So pick yourself up some wire brushes. Thanks for watching. Goodness, goodness, goodness. So pick yourself up some wire brushes. It'll help you keep your work clean. It's a good tool for